we're going to look at the characteristics of a quadratic function, but today instead of starting with a graph, what we're going to do is we're going to start with an equation. What you need to do is you need to take this equation and turn it into a table of values and then put it on your graph. And I'm going to be showing you how all these things are related as we go through this process. So the first thing I want you to notice is in this equation we have vertex form. And in vertex form we can see our vertex, which is going to be right here and right here. So the vertex of this function is going to be at 2, 1. We want to put that vertex in the middle of our table, okay? And then we can also put that onto our graph. We go over 2 and up 1. This is where our vertex is going to be. Now if we look, we can also see our a value here, which will tell me that this parabola is going to open up and it's going to be stretched by a factor of 3. Which means it's going to be a little bit skinnier than our regular parent graph. Now, the easiest thing to do when we have a function like this is to create a table of values first. So that's where I'm going to start. So in order to create a table, I'm going to start with my calculator here. And I'm going to go to my y equals function, and I'm going to type in this equation exactly the way it looks. So 3 parentheses x minus 2, close my parentheses, squared, plus 1. Here's another little strategy here. Remember how I said that vertex was 2, 1? Sometimes kids get confused because when they look at the equation it says negative 2 and 1, so they might think that's where the vertex is. But if you look at your graph, you can clearly see we go 2 to the right and up 1. The other thing we can check is our table. So if you look at your table, you'll see if you go to the x value of 2, the y value is 1. And then if you look at those y values, if you go to 1, you've got 1, 4, and you've got 3, 4. And you can see that this is where our y values start to be symmetrical, and that's where our parabola is. So what I'm going to do is I'm going to take these values from my table, and I'm going to copy them onto my table over here. So here's what we got from our calculator when we put this equation in. And now I'm going to take these values and I'm going to graph my parabola with them. And this is what we're going to see here. Okay, so now that I have this graph, it's time for us to start looking at our characteristics and how this has changed. So we'll start with question 1. How has the graph transformed from the parent function? Remember, our parent function would start here at 0, 0, and it would have an a value of 1. So it would have kind of a slope of 1. It would look something like this green one here. So what I'm going to do is I'm going to think about how it would change. How did the vertex move? Well, when I look at this vertex, I can see that the vertex moved 2 places to the right and 1 place up. So when I write its transformation, that's what I'm going to say. My vertex moved, the vertex moved 2 places to the right. It also moved 1 place up. So it moved 2 places to the right and 1 unit up. Okay, that's 2 ways this graph has changed. It actually changed a total of 4 ways. Okay, well actually there are 4 characteristics we want to look at. One of them didn't change, and that's one I can see with my a value. My a value is positive, so this graph, it opens up. Okay, now my parent function would also open up, so that's not really a change, but it is something we mention when we talk about its transformation. The last thing we want to talk about is whether or not it's stretched or compressed. And with my a value of 3, I can see that this function was stretched by a factor of 3. And when we say it's stretched, that means it got skinnier. Okay, stretched by a factor of 3. And the factor it stretches by just matches that a value up there. Okay, so that's my transformation. Now we're ready to start talking about these other characteristics. So my vertex, what is a vertex? Well, this red dot down here is my vertex. Okay, the red dot, when we talk about our vertex, what I want is the ordered pair that I have here. And the ordered pair of this vertex is 2, 1. So 2, 1 is my vertex. And if you look, 2, it moved 2 places to the right, that's my x value, and 1 unit up, that's my y value of my vertex. Is it a minimum or a maximum? Well, if we look at this vertex right here, it's at the bottom of my parabola. Since it's the bottom or the lowest point of my parabola, we would say it's a minimum. So I'm just going to put a box around minimum there. Now my axis of symmetry. The axis of symmetry is the line that goes through this parabola and divides your parabola in half. That axis of symmetry goes directly through your vertex. And the equation for that axis of symmetry, not x equals 3, is x equals 2, because my x value of my vertex is 2. So my axis of symmetry is where x equals 2. Now this is really important, because if that's dividing my parabola in half, everything on this side of x equals 2 is going to be greater than 2. And everything on this side is where x is less than 2. And that's going to be really important when we identify our values for our increasing and decreasing interval. So my increasing interval and my decreasing interval, I'm going to look at my parabola and kind of trace it and see what's going on. You read a parabola from left to right. So I'm going to start here, and I'm going to trace this parabola. And what I want you to notice is when I trace it, I'm going down. And when you go down, we say we're decreasing. So this side is the decreasing side of my parabola, which means this over here, this x is less than 2, that's my decreasing interval, because I decrease from the top of my parabola all the way till I get to that axis of symmetry. And when I hit that axis of symmetry, it's my turning point, my parabola starts going up, 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 up. So I can say that this side of my parabola is my increasing interval. And my increasing interval is going to be where x is greater than 2. Now I want you to notice, notice this. The x value of your vertex, the axis of symmetry, and your increasing and decreasing interval are all going to be the same number. It's all going to be based on that vertex. My domain involves all the possible x values I could put into this function. So if you think of your table, if we look at our table goes on and on forever. Every x value, whether it's positive or negative, I can keep putting in x values. There's no limit on the x values I have here, and we can tell that because we have two little arrows on the ends of this parabola, which means it's going to keep going on and on forever in both directions. So the domain of this parabola is going to be from negative infinity all the way up to positive infinity. We could put in any x value we could dream of, and it will work. We have two more things to talk about. One is our range, and our range is going to be limited by where our parabola is. I've got a little bit of cleaning to do here, so hang on for 1 second. Let me clean up this parabola so we can take a look at it here. I'm going to put my axis of symmetry back because I want us to be able to see that. But I wanted to get rid of some of that other writing. When you look at this parabola, what I want you to see is it ends right here at this spot. My parabola is completely above this line. And if we look at that, that's where y is 1. That's the lowest value of my parabola right there. My entire parabola is above that. It keeps going up in both directions. So my range is going to include all of the y values that are greater than or equal to that value of 1 of my vertex. And then finally, last but not least, the last thing we want to look at is my x-intercepts. So again, let's clean this up here a little bit. My x-intercept is going to look at the place where we cross or touch my x-axis. Now, do I cross or touch this x-axis anywhere? I do not. And since I don't cross or touch that x-axis, we say we have 0 x-intercepts. And that's how you identify all the characteristics of a function when you're just given an equation.